In this lesson, we really want to make some connections between the ideas of algebra skills, and quadratics, and the idea of our shape and the properties that we want to identify. So basic examples today, okay? So we've got a quadratic form, quadratic equation in standard form, but it's not quite in standard form. It's actually not in the right order. So the first thing we want to think about is we should always put things in the correct order before we start. So it goes from the highest exponent to the lowest exponent. That way you have standard form A, B, and C. We want to take that equation in part A here and express the relation in factored form. In other words, we want to factor it. So objective one is, can we make it simpler? Can we make it easier? The first thing I notice is they're all even numbers. I also notice my squared term is negative. So I want to make that squared term positive, and if I can divide something out, I'm going to try to. Now, it'd be nice if I could divide them all by a -4, but unfortunately 22 isn't divisible by 4. So the most I can take out is a -2. I'll be left with a 2x squared, and remember we're dividing all these by -2's, right? Okay, so I'll get minus 11x and plus 12. So I'm left with an expression that's a trinomial, but because my value inside the bracket at the front here is more than 1, it's a complex trinomial. So I have to apply the idea of man plus. I'm going to multiply the first and the last together to make a multiplying number of 24. I'm going to have to add to -11, I'm going to have to figure out numbers that do that. The numbers I can come up with are -3 and -8. So I'm going to go back to my equation. I'm going to keep that a value up front, and I'm going to replace the middle number, the -11, with my two new numbers. I like to put the big one first and the small one second. I'm then going to have to split it in half down the middle and common factor. Now, they're both divisible by 2x. So I'm going to have x minus 4. Bring down my sign. And what can I divide out of these two things? Well, I can divide 3 out of them. And we're left with x. The plus 12 divided by -3 makes -4. And I know I'm on the right track for the bracket matches. So my last line is my -2 up front, my common bracket, the x minus 4, and the leftover stuff, the 2x and the -3. And now I've got factored form. So I've done part A. Part B, determine the zeros. The zeros I can find from factored form, and I can find them pretty quickly. Okay? They're called zeros because they're what makes the equation equal 0. Well, this happens if x is 4. This one over here happens, well, it happens when 2x is equal to 3. Or in other words, x is 3/2, or 1.5. And then part C, the vertex. I have options on my vertex. Option 1, I can find the axis of symmetry by averaging my zeros. So 4 plus 1.5, that's just the decimal version, divided by 2. That gives me 5.5, or 2.75. That's option 1. And some people love that option, averaging your zeros. Option 2 is I use my formula in standard form, -b over 2a. If I go back to standard form, way back up here at the top, b was 22. So now it's going to be -22 over 2 times a, and a was -4. So we get -22 over -8, which hopefully, just hopefully, comes out to 2.75. And it does. So either way, I have my x. X is 2.75 or x is 2.75. Either way, I need to figure out the y. Now, if I continue with this format of factored form, I can plug the 2.75 back into factored form. So that'd be my -2, and then 2.75 minus 4 in one bracket, and the other bracket was 2x minus 3. So 2 times 2.75 minus 3. And then I can do some BEDMAS. I get -1.25, and then I'll get 5.5 minus 3. This way works just fine. It's a little time consuming, a little bit maybe. Not too difficult though. And then I gotta multiply this all together. So 2 times 1.25 times 2.5 gives me 6.25. So my vertex is 2.65 and 6.25. That's option 1. Or I could use my standard form version. My standard form version was, go back to the top, okay? I had an a of -4x squared. So -4 times 2.75 squared And then I had a b value of, was it 22, I believe, right? Plus 22, x. And then I have my c value of minus 24. And if I put all that in my calculator, shockingly enough, it comes out to the same answer, 6.25. So either way, I can use factored form or standard form. They're connected. They're just different formats of the exact same question, right? Just depends on what set of information you want to use. This can kind of be up to you to decide. All right, let's look at the next one. Word problem with an equation. Studies have shown the admission in a high school basketball tournament can be modeled by this equation. X is the number of tickets, okay? And in hundreds, that's important, and P is the profit. Part A, what are the break-even points? A break-even point, the definition of that was where you make zero profit. So really, I want to know if profit is zero, what is the answer to this equation? What are the zeros? What makes it come out to zero? Well, I know I can find my zeros, not from standard form, but from factored form. So I have to factor this. So if we factor this, let's take out that negative 100. I'll have x squared minus 14x and then plus 24. Well, now I've got an equation I can put in factor form, find my zeros. That's a little bit simpler. In fact, it's a simple trinomial. It multiplies to 24 and adds to negative 14. Well, two numbers that do that are negative 2 and negative 12. So I can replace or change the format back to factored form. I did this so I can see my zeros because I want to know what makes my profit come out to zero. So x is 12 or x is 2. And what did x stand for? X was the number of tickets sold in hundreds. So if 200 or 1,200 tickets are sold, they will break even. So their costs will be equal to their revenue. The amount of money going in, the amount of money going out, balance each other out. They aren't profiting yet, they're just breaking even. Okay, part B. What is the maximum profit? Oh, the maximum profit. And C, how many tickets must be sold to maximize profits? So both of these questions involve the word maximize, maximum. We know that maximums happen at the vertex. So without ever asking us, they're telling us to find the vertex. How can we do that? We've got two options. We can average our zeros or negative b over 2a. Now, I have my zeros right above me. I can see them there, so I might as well use those ones. My axis of symmetry, 12 plus 2 over 2, 14 over 2, 7. And if I plug it back in, y equals, actually it's not y, right? It's p for profit. Profit equals, I had an equation, I think, right there, negative 100 times 7 minus 12 and 7 minus 2. What's that going to give us? 100 times negative 5 times 5. I think that's 2,500. So I can answer B and C at the same time here. Okay, the vertex was what? 7 and 2,500. Your x and your y. What does that mean? A maximum profit of, actually it's not x and y, it's x and p. P for profit. A max profit of $2,500 is made when 7, that's what x is. Remember, it's in hundreds, so 700 tickets are sold. We made a connection. Okay, try another one. A golf ball is hit off a tee. Its height above the ground can be approximated using an equation where h is our height in meters and t is the time in seconds. What are the zeros? I can't tell by looking. I need to factor this. Now, I hope you noticed it was out of order. So let's fix it first. And then let's factor. Now this one has a common factor involved. I can divide them both by negative 4t. I'll be left with t minus 6. And from that, I can see my zeros. One of them is 0, just t by itself, and one of them is 6. So for part B, when does it hit the ground? Well, now that I have my zeros information, I can actually draw the picture out, right? Starts at 0, ends at 0, and that's 6 seconds later. So for part B, it hits the ground after 6 seconds. That was quick. What are the coordinates of the vertex? Well, I can find the vertex. Vertex is not too bad. I have the zeros or my negative b over 2a. Now again, I have my zeros. They're right here. I might as well use them. Notice I'm using t this time instead of x because that's the variable I was working with. So 0 plus 6 over 2 is 3. 3 seconds. So it's going to have a max after 3 seconds. That's what part C was asking, right? What are the coordinates? Oh, the coordinates of the vertex. I'm not done. I need to find y, or in this case, h. H equals, I have an equation for it, negative 4 times t minus 6. So negative 4 times 3 times negative 3. That's 36. So I can actually change this wording a little bit. I can say the vertex is a max of 36 meters after 3 seconds. That's my vertex. Okay. Oh, look, I've answered part D. By finding my vertex, I've found the maximum height and when it occurs. It's really what a vertex is. It just has context to it, meaning it has words attached to it. All right, last one. The area of a rectangle is given by this equation. Can you find expressions for the possible dimensions of this rectangle? So we need to think to ourselves, what areas of rectangles? What do we know? We know the area of a rectangle is found by the length times the width. In other words, 20x squared plus 3x minus 2 equals something times something. Well, doesn't this kind of look like factored form? So if I can factor my expression, I can actually figure out expressions for length and width. So I need to think to myself, what kind of factoring do I have to apply? This looks kind of like a complex trinomial. So I need to multiply my first and last and find numbers that add to the middle and multiply to the negative 40. And things that do that are 8 and negative 5. So I'm going to take my expression, keep the first term the same. I'm going to replace the second term with the two new ones and write down the last thing. We'll cut it in half and common factor. Yeah, take down the minus sign. Nothing common, so take out a 1. 5x plus 2. My brackets match. Great news. That's my common bracket and my leftover bracket. So I've taken something that was FOILed and turned it into a length times a width. I've got myself some dimensions. Okay, part B, determine the dimensions in the area if x actually equals 2. Well, I can do that now. So my length would be 5x plus 2. We know that x was 2, right? So we can say 12. I think our units were centimeters, were they not? Yeah. Okay, and I know my width was 4x minus 1. But we said x was 2. So basically we're taking our thing and plugging it back in, right? I got 7. And I know my area is just length times width. So it's 12 times 7, or in other words, 84 centimeters squared. And we're done. Okay, so some simple applications of how we can use quadratics. So a couple questions to try. I want us to be comfortable with going from standard form to factored form, different types of factoring involved, so simple, complex, or even just a common factor, and going back and reminding ourselves of how we find a vertex and what those kind of points mean.